This is the Amp Hour Podcast, recorded July 21st, 2014. Episode 208, with guest Nadia Peak, Gallant, Gcode, Gerontology.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
Man, I feel bad that I don't have a radio voice, but I'm Nadia Peak.
You're doing good. You're doing good.
I'm Nadia Peak. I'm a PhD student at the MIT Center for Bits and Atoms.
Welcome.
Oh, okay. So you're a student there.
Yeah.
Yeah, but like, you know,
how's that going?
Students are also like in charge, you know, like that kind of thing. PhDs, right?
Especially the PhDs. So how long's your PhD taking? Like forever? Are you one of those professional PhD students who just enjoy the lifestyle and just live there for 10 years?
You're starting with the really kind questions, aren't you?
You know, at MIT, though, I would live there forever, I bet. I don't know.
I'm totally going to graduate. One day.
Okay, one day.
All right, let's get that straight. I'm a serious researcher who eventually will no longer be a student.
All right.
But then you'll have to go work in the real world, and that sucks.
Will I?
Well, maybe.
Well, I don't know, but yeah.
We were talking. Well, Nadia, what was your? We were talking before the show. I asked you about what your criteria eventually of working is. I thought it was a good answer. So what is your eventual criteria for post research world?
Well, I guess it applies to research world too, but in general, I would like to work with not assholes on shit that isn't boring. And
that's awesome.
well, that's what the real world is, unfortunately.
Yeah, it turns out that it's a much more constrained space than I originally expected.
Right.
But
although it's a lot different these days because there's lots of, there's Google Labs and there's all sorts of other, weird and wonderful, hardware startups that are working on wacky stuff and all that.
Have you met anyone from Google recently?
No, I've heard grumbling. So well, apparently it's exciting. At least you are working on something exciting, as opposed to me who worked on.
They say that it's exciting, but then they also say that they can't tell you what it is.
Yeah, that sucks, doesn't it? Not being able to, being under NDA. Boo.
Yeah. I'm not so sure about it. I also think that it would be cool to work on technology that has immediacy in its application as opposed to working on technology that happens to be the whimsical desire of whoever.
Well, unfortunately, to get that wish, you have to work on the boring stuff. The immediate stuff is usually, not always, but probably in the vast majority of cases, the boring stuff. Unfortunately, it's,
like the impactful stuff, you mean?
Get into market.
Oh, well.
Yeah.
Yeah, but Nadia, you're in the research space, right? So maybe it's a different definition for you.
It's, totally.
Of what's not boring?
No, of like what's immediate as well, like what's needed in the...
Yeah.
Yeah, Dave's talking development side, right? And if you're on the research side, there's always
I'm talking
contrast.
a product that makes it to the market, be it a consumer market or a niche engineering market or something like that. Yeah, it's usually... a new version of a product, or it might be a whole new product, but it's still boring. It's got to go through, production, which is one of the most boring aspects of product design, is getting something into production and out there.
Is it? I think, well, some parts.
Well, some people enjoy it. Some people, but generally, it's pretty boring. Got to admit.
Okay. All right.
Sorry to all you... or you production engineers out there who just love it and just can't get enough of bill of materials and dealing with suppliers and the assembly houses and, tombstoning components and whatnot.
So how about this? Let's get a reference point here. Nadia, could you tell us about your work? Because I think that's the reason why you're here, and I think it's actually really interesting stuff. So maybe kind of leading up to it, too, how you got into it.
Okay. So I mostly work on the machines that make project at the Center for Bits and Atoms. And so I don't know if you're familiar, or I'll briefly introduce the concept. I'll start even earlier. The Center for Bits and Atoms is a kind of a collection of misfits, or a salon de refusés, as they like to call it. We're not.
What is that, French or something?
Sounds like, yeah.
And so we're not in the mechanical engineering department. We're not in the electrical engineering department. We're not in physics. Everybody that's there.
So you're in Willy Wonka's chocolate factory?
Pretty much.
Is that
pretty much?
Right. Okay.
And so way back when the Center for Bits and Atoms first started, one of the things that they were interested in is reinventing manufacturing across length scales, so from the angstrom to building size fabrication, and also rethinking computer and processor design. So these are a bunch of the people that back in the day worked on quantum computing and things like that. And so to be able to fabricate the experimental test beds that they needed, they wanted a lot of equipment, and so they applied for funding from the National Science Foundation, and the National Science Foundation was so kind as to award them, let's just call it, a lot of money.
Metric butt tons.
Yeah. And so when you receive a large quantity of taxpayer money for the purpose of research, generally the NSF or people like the NSF want you to do some kind of outreach so that other people understand what it is that you're doing and how you're doing it. And most people do that in the form of like a pamphlet or a white paper, or they say, oh, this is what we do, or they'll do a magazine. And so at CBA, they thought that sounded kind of boring. And so we had...
Well, it is.
Right. And so we had, because of this grant, there was a whole fabrication center that was started that had water jet cutters, but like scanning electron microscopes, like that range of length scales. I don't know all of the things that were bought in the beginning, but I would say that now we have, I don't know, several $1 million worth of fabrication equipment, focus ion beam up to like wire EDM. And so what they decided,
sweet. Yeah,
it's pretty fun. And so what they decided that they were going to do was to create a kind of analogous lab with some of the more accessible and cheaper digital fabrication machines in kind of inner city Boston, so that anyone who wanted to use them would have access to them, not just researchers at the Center for Bits and Atoms. So they put into that space that they called a fabrication laboratory, or Fab Lab. They put a laser cutter, like a 35-watt laser cutter, a small format milling machine, a larger milling machine for doing kind of 4-foot by 8-foot sheets of plywood, and a full electronics workbench with a bunch of components that you could do some basic circuit design with. And they kind of just looked at how things would grow from there. And it turns out if you give people access to digital fabrication equipment, they like making all kinds of things that you wouldn't otherwise expect them to make. I think some of the popular things that were made at the original incarnation of that Fab Lab were like a browser for a parrot so that the parrot wouldn't get bored. And I don't know, like alarm clocks that were unconventional.
The ones that ran away or something?
Yeah, that one came actually, just the one that ran away actually came out of a class that was taught by my advisor, Neil Gershenfeld, at MIT. And so people were making all these kind of funny stuff, but it turns out that digital fabrication equipment is still kind of annoying to use because there are these interfaces that are kind of designed for industrial process, or for like it's not necessarily something where you're like, oh, I'm going to use this laser cutter 10 times, so I want the interface to be something that I don't necessarily have to do any training to learn how to use. It's not really quite like that. And so because of that, we have some projects ongoing at CBA where we redesign both the design software and the CAM software. So how you control the machines is kind of one unified open source interface. So you don't have to learn all of the different whatever nonsense machine format streaming software that goes with each individual machine. It's also it's kind of the last thing that they think about, where they're like, oh, we made this machine and now we have to make a driver for it.
Yeah. you know you love Mach 3. Just admit it. Everybody loves Mach 3. I'm kidding. No one likes Mach 3.
Yeah, exactly. And
I'm going through the page of all your tools here, all the tools that you have in the lab, and like I'm just, I'm drooling, right? And then I get down and it goes, there's a sewing machine.
Of course.
It's like, of course, okay. It's like all these, there's got diamond laser saws and cutters.
Two
and
sewing machines. One of them is
wow.
CNC controlled, and the other one requires 3/5 power. So both of them, I would say, are pretty badass sewing machines. I don't know if
the
you're
one
trying
can
to be
go through like
dismissive
leather
of sewing machines, but sewing machines are super awesome machines. I think you should take that back.
Well, it's just a picture of like a tiny little desktop thing here, just like something that you do for your kids' clothes.
Which one are you looking at? The
I'm looking at the tools page. Here we go. I'm looking at the tools page, and like halfway down, there's this. Just this little sewing machine in between all these, high power laser, plasma cutters, diamond saws, and wire bonding machines, and
this is the programmable one. So this can do embroidery and stuff like that. I think this is the CNC one. Yeah.
Oh, okay.
So
right.
I was going to say with this sounds all very familiar if people have read the book Fab by Neil Gershenfeld. So that's like the...
I haven't gotten to the part yet where I tell you about what I actually do.
Oh, yes. Yeah, that helps.
That's why she's here,
so this is part of your this is what your PhD thesis is on.
No, I haven't gotten to that part yet either.
Okay, well.
All right, we'll quiet down a little bit, I guess.
Okay, so machine tools are annoying to use. And the interfaces are annoying, and then also they're kind of expensive. Like, not in general, they're expensive, and they're also sometimes they're just unjustifiably expensive, I guess, because there's not a whole lot of demand for them. And the manufacturers often have kind of a stranglehold on the market. And because you have access to precision tools when you have digital fabrication tools, you can use those tools to make stuff like parrot browsers, or you could make more digital fabrication tools. So my, I would say, hobby and research is using digital fabrication tools to make more digital fabrication tools. Not necessarily that make themselves. People always ask about that. So I'm going to preempt your, are they self-replicating with, no, they're not.
Yeah.
Neither is RepRap. Let's not kid ourselves here, folks. I mean, I guess they could print parts, but come on. It's not like they're actually making themselves.
Yeah, well, I guess that the RepRap project is fun because people get really engaged with machine design because of that. And I think it's kind of an underappreciated aspect of creating automated tools. So I work on the software for controlling machines. I work on electronics for controlling machines, and I work on machine design. Sometimes I make machines that are just kind of smaller, cheaper versions of machines that already exist. And sometimes I make purpose-built machines that are only for one thing, but because making machines is a fast thing now as opposed to a slow thing, making a purpose-built machine is not a problem. And sometimes I work on really silly machines. So that's my research. And my PhD topic is specifically if you look at the different parts that are required in machine design, there's a mechanical part and an electrical part and a software part. Each of those are kind of pretty established fields on their own, but the integration between them is all let's call it a little bit painful.
Yeah. I love going through 4 programs to get something cut on my CNC machine. I know what you're talking about.
So your thesis is about making that easier?
Yeah, sure.
Or making them become one?
So my thesis is about kind of using the same paradigm for, like, if you take the spatial configuration of a machine, and the machine also has a network of nodes that represent like the motors and the sensors and the actuators that the motors are talking to. then how do you get all of those? How do you get all of those to fit kind of structurally within the same framework, so that as a machine designer / machine user / machine part designer, you're always looking at something that kind of has the same layout.
Mm. So like abstracting to directions versus an actual. Instead of like talking about a motor, you talk about what direction it moves in software. Is that kind of the idea? Or
Yep.
I remember you showed some of this stuff at SolidCon, but it's a little fuzzy now.
So exactly. And then that's like the mechanical layer, and then also the control layer. So I don't know how detailed you want to get about this, but so let's go deep.
Yep.
And
our audience can take it. I think they'll at least go look it up afterwards if they need to.
Okay. So the way that a lot of machines currently are controlled is you have like some CAD program. You have some CAD program, and then you take that CAD design and you use some CAM program to generate Gcode that you use a post for that is specific to your machine. Then you stream, or you click the awesome button, for example, on a Herco or Haas milling machine that says load tape.
Really? Is that what it does?
I mean, no, it's a USB
from back
stick.
when it used tape, right?
Yeah, exactly.
Like the actual.
But the button is still called load tape, but now it's a USB stick. And so you put in generally like the DRM USB stick to load Gcode, which is not a Turing complete language, commands onto your milling machine, which it then executes. And if something goes wrong, you have to kind of guess where in the Gcode streaming buffer you are. And you don't necessarily know anything about the position of your machine, which was great 50 years ago before, your control clock cycle would be fast enough to necessarily stop on time if something went terribly wrong. But
there's no real time machine necessary because there's nothing but real time, right?
Yeah,
clunking through instruction at a time on a punch card.
And so instead of using Gcode, I use something called a virtual machine. So this has all kind of been developed a lot at CBA, going back before my time too, with people like David Kopp and also Alon Moyer, who I work with a lot. But virtual machine control, where you have a machine where all aspects of the machine, so say all axes, or if you had, say it's a 3D printer and you have like a thermistor on it or something, all of those are different nodes on a machine network that are represented in your virtual machine. And so then to be able to move your machine around, instead of streaming Gcode to it and having some PLC or something do interpretation of the Gcode and turn that into the acceleration profiles for your motors, you're calling functions directly on nodes on a network that are the machine. I don't know.
I was going to ask you what you thought about G. Like, what is your feeling about Gcode? Is it like?
I mean, Gcode was great for my grandfather.
My grandfather was a machinist too, actually.
My grandfather wasn't a machinist, but I mean, just in terms of
mine was, but he got put out of work by CNC machines.
Right.
Yeah.
That's a whole nother. That's a whole nother story.
Right. Yeah.
And I think I think that CNC and automation, it's a conversation that is always kind of awkwardly angled into labor politics, and so take architects, for example, right? Architects make some design and they have kind of, not to generalize too much, but often they have little regard for exactly how
reality.
or just how something might be made, and when like Frank Gehry designed that opera or Disney concert hall and tried to specify a bunch of sheet metal to within 1/16 of an inch tolerances, everyone was like, this person is fray. but you can kind of catch up with that by building, Gehry Technologies developed a lot of interesting ways of making sure that they were manufacturing things to the specification that they needed. And it kind of moved technology forward. And with that, you create a lot of new jobs that are about developing new technology. And so if you say, okay, how do we incorporate educating people in new advanced manufacturing techniques into the design of advanced manufacturable things, that's an interesting conversation. But just to say, hey, CNC is putting people out of work. Yes, that's technically true if you look at it in kind of a small zoomed in way.
Oh,
but I think that really the obligation that we have is to invent technology that accounts for how people are going to use it, who's going to use it, and how people are going to be educated to use it. And in the case of Gcode and the 17 million different like workarounds that you have to go through to get from one place to another, and the like 180 hours worth of training that somebody who like would use a 5-axis Mori Psyche milling machine would have to do. That's just not feasible. It's not something you can expect. And so I think having a new generation of competent engineers who are able to interface with electromechanical systems is really important, and it's not reflected at all in the way that we design things, and that's a problem.
So I always look at this as like one reason this stuff persists is it's kind of a lowest common denominator too.
Yeah.
And so it's like people understand. Okay, I at least can take Gcode and put it through a converter, and my machine will understand it. And same thing with Gerbers, right? Gerbers are still around. I'm sure Dave has lots of opinions about this. Gerbers are still around because fab houses take Gerbers, right? And it's this lowest common denominator. Same thing for PDFs, right? Even for schematics and stuff like that. So I guess my question for you would be, how do you then standardize and not have the splintering that would be necessary? I mean, do you have to do everything custom then from now on? So like, I'm not sure what the actual format of this language looks like then, but like, how do you standardize across machines, and do you even bother to?
Yeah, I think that's so at least the way that I control machines, you can still also stream Gcode to them. It'll just convert Gcode into move commands. And I think that software is kind of the easiest thing to prototype. You just have to build into your software the capability for people to extend it. People love extending software and writing widgets and tools and plugins. So the way that I write all the move commands is just you create a virtual machine in Python. I don't know. I think it's relatively straightforward to extend, and it's kind of my expectation is that people would interface with both the software and the machine. And maybe that's an unfair expectation. Maybe you would say, like a machinist doesn't actually want to write any code. But I don't think that going forward that's going to be true. And so I'm just gonna place myself there in the position. My position.
Plant your feet, huh?
Yeah.
Speaking of software and Python, what when you want to do something new, okay, we're going to write this. What decisions go into making the choice of which language you're going to do it in? Is it because, that's the favorite one, or I think that language is more suitable to do this particular job, or is it?
Yeah, I think it is always changing. I think everything that you can do one way, you can also do another way. And I think you just have to accommodate lots of different users and how they might do, and how they might want to use a tool. I'm a big proponent of modularity. And so,
but what about
like
software obsolescence? Yeah. What about software language obsolescence, though? Like, it's not like you're going to make a choice. Oh, I think Pascal is the most suitable language to write this in.
Right.
But you're not going to, that would have been great 25, 30 years ago, right? That would have been a sensible choice. So. Right. Does that come into it? Like, no, nobody's using this language anymore, but it's the most suitable. Fourth is fantastic to do this in. It's so efficient. But
Lisp,
yeah. I mean, the list is endless. How does that factor come into it? That you think, look, 10 years down the track, nobody's going to be using this language. So we're writing our software for 10 years down the track. So do you have to make a compromise?
I guess. Maybe, but I think even more so, I think that the way that you architect and implement systems, you have to acknowledge that somebody's going to re-architect and re-implement it probably within a few 5 years or so. Let's call it that.
Okay.
And so if you, for example, are Epilogue laser cutter and you make a file format that you don't document, then it's going to be
a dig coming on.
Then it's going to be really hard for someone to write a new software interface to your machine because if you don't understand your file format, how is anyone else supposed to? And so I would say that that's the more important aspect of it, and choosing what, I'm not religious about any kind of software. The people on this radio show, guys, made me reboot into Windows.
She knows. She
had to say it.
Yeah, we had some issues with the Ubuntu build of Mumble.
You said I would.
I know. I said Dave would do it
me
first
before the show.
Yeah, I owe Dave $5. Yep. Thanks, Natty. Yeah, thanks.
No, but I guess I am acting sort of disgruntled, but I actually don't really care. It's just kind of funny. Because, at the end of the day, you guys are trying to record audio, and this was the fastest way for us to get to recording audio. And so if you want to write something in JavaScript because kids like JavaScript these days, then
I thought JavaScript was on the way out.
Who knows? Okay, go. Whatever.
Okay, sorry, I'm not up with it. I'm not hip and young.
Go doesn't seem like a very hip language, though. It just kind of seems like refactored C to me, but I don't really. What do I know?
Erlang. Let's switch to that.
Erlang is not hip.
I'm just listing things that I've heard of at this point. I don't even know anymore.
I guess it's a maybe this is like a philosophical discussion about whether or not you expect your users to be able to modify the tools that they're using or not. And I think that users should be modifying the tools that they own and are using to make them more suitable for themselves. And if other people think that languages are a barrier to entry, or having to do both software work and electrical work is a barrier to entry, then we should be making that easier and not trying to make the interface dumber.
Got it. Although that can lead to people branching the project off into other ways that then make it not compatible and not giving back. So is it better to allow them to do that, or to try and, for like one program to try and do it all, so to speak?
I think that branching off is actually pretty great. I think that having custom machines for specific purposes is actually a really great outcome. I think that it's
always the best. The right tool for the job is always the best.
Yeah. So I'm not concerned, I guess, about people not wanting to contribute to the grand solution of all machine problems ever.
Okay.
Right. But
one machine to rule them all.
Yeah. Yeah.
So what about the assertion then? Like, so when I was buying a milling machine, someone advised me buy a tool, not a project, right? Mm-hmm. And even the tool I bought, there's no such thing really with CNC machines. I think I found out, but like, what about that though? Because I feel like that's part of the underlying thing here. You're talking about people modifying the machines, and that's a very good thing. But a lot of times, both the companies selling machines and also the people buying machines want to just buy something to use and move on, right?
Yeah. Well, I think it has to do with the maturity of the machine tool that you're dealing with, right? Like people buy kind of kit CNC milling machines, and they come with like some motor control box that they want you to control from Linux CNC, and you have to find a computer with like a parallel port. And
Yep. I know those feels.
and so I think that has to do with the maturity of that kind of project, CNC, like CNC machines, and I would say that I don't have one of those because I don't have a computer with a parallel port. God.
And I use a USB to parallel converter, for the record, folks.
I'm sure those level conversions are going great for you.
Yeah, it's awesome. Crashes about once every 40 cuts.
and I think that makes it or like pretending that is further along than it really is a detriment to that kind of machine tool development process. And one place that I think is kind of an interesting crossover is that people seem to have like not a very clear distinction between robots and machines anymore. So what what is a robot and what constitutes just a machine tool, because machine tools are getting more sophisticated and robots are getting more accessible. And somebody pointed out to me recently that the way that I control machines is kind of similar to like a robot control language. I think that's entirely true, because I'm thinking of the way that you might think about different joints on a robot arm. I'm thinking about machine tools in the same way. And so robots are designed, or robot arms are designed, that you probably would put your own end effector on it and might want to interface your robot control system to also control the end effector. I can't say that I think that they're doing a particularly good job of that, but it's something that's kind of built in. And
what is the difference between the two? I'm sorry, I don't know the difference, I guess.
Well, it's just you wouldn't necessarily stream Gcode to a 7-axis robot arm.
oh, watch me do it. I will break some shit.
Yeah, I mean, like you could probably write.
Stand back.
You could probably write an interpreter that would take Gcode and like do the inverse kinematics and figure out how to map the coordinate system that your Gcode is in to whatever you decided to set as the coordinate system for the robot arm, I guess.
Uh-huh.
Mm-hmm.
But that wouldn't be common. As opposed to like a machinist would say, yes, I'm going to take Gcode and load it into this machine, and I'm just going to set the coordinate system with G60 or whatever the Gcode command is for that.
So is the difference just the complexity then, and the requisite like abstraction layer that's necessary because of all the dynamics you have to do for robots? Is that the difference?
I think that the difference is just the people that the history of how you would program the machines. With robots, it doesn't have necessarily the same historical baggage of how you expect it should be done. So when people are like, oh yeah, I'm going to build like a Rhino grasshopper interface to moving around the 7-axis robot arm, everyone was like, great, that seems like a great idea. That seems like something we can do. Whereas if you would say something similar and want to hook it up to a CNC milling machine, I think
a Haas VF3.
Yeah, I think that people might be recalcitrant.
Well, you'd have to pay another $20,000 for. I was talking to Nick Pinkston about that. He's talking about like buying another 2 megabytes of memory or something like that for, or 2 gigabytes for like $20,000 or something crazy like that. It was, it was basically because of the market. They were cornering the market.
And I don't think it's even I don't think it's even like people being nefarious. Like if you take, for example, weaving machines, right? If you take industrial looms, I think that every line that you want to program in a weaving machine is called a pick. And so industrial looms have 80,000 picks. And if you want to have one that has more than that, you have to pay a lot of money. And it's not because it's conceptually a hard thing to do. It's because it was never really designed for that in the first place. And so you're paying someone to like hack their own system and figure out how they could make it work.
All right.
And
you're front loading NRE basically into the price of the part.
So I think it's like a development cycle difference, where robotics is something that is used to a quick development cycle and machine tools are not used to a quick development cycle. And so interfacing with them in different ways has different expected outcomes. That is a semi-articulate argument for why machines and robots are converging.
Second PhD right on the line right there. I mean, I'm just saying,
Right.
So what about some of these machines? So I got to see some of these at SolidCon, like I mentioned. But could you explain just kind of they're kind of discrete pieces. They're modular. You can kind of bolt them together and do interesting things with them. But just what are the pieces, basically?
So that's just the machine. That's just the machine that I brought to Solid. That's a series of machine tools that I was developing with James Coleman. So before so at the Center for Bits and Atoms, we teach 4 classes. One is like a physics class and one is like a math class. And then there's one class called How to Make Almost Anything, which you might be familiar with if you read Fab. And then there's another class called How to Make Something That Makes Almost Anything, which is about machine tools. And so in the not the most recent, but the one before that, machine building class, one of the things that came out was we want to do circuit mills, because the way that people in Fab Lab like making circuit boards is by milling them. You don't get you can't make very complex circuit boards that way, but it's a really fast process. And the circuit board mill that was being sold in the Fab Lab was the one that we thought was most expensive per unit output.
Is this the Modelo?
Yeah, exactly.
Those things are so crazy expensive. It's unbelievable.
They're made in Japan. They say that the inside of them is actually quite nice. But yeah, it's $5,000 for not a very fast machine, with high precision, but not very high precision. So that was kind of the first target unit. And so we worked on making replacement circuit board mills. And there were a lot of people that worked on replacement circuit board mills. Jonathan Ward, who now works at Other Lab, which also had the spin-off, the Other Machine Company, which is also making circuit board mills still, was one of the first ones. David Carr made a circuit board mill version. And so that was kind of the start of these projects, and controlling those circuit board mills was annoying, because that's how we realized that there isn't really a good solution for rapid prototyping of control systems for machine tools. So that's kind of where we started working on virtual machine control. So I don't know if you've seen the MTM Snap, but it's a circuit board mill that's made out of cutting board material, HDPE. So you can get in lots of different FDA color code approved colors.
Oh, yeah.
And it has like a bill of materials, maybe $400 instead of $5,000 for the Modelo. And then that was cool, and it was small and cute and portable, and we could like carry it around and mill circuit boards on the fly. And then we decided that would be a cool thing to have even smaller. Oh yeah, and 3D printers were always sort of in the background of machine tools that are easy to prototype. The nice thing about 3D printers for prototyping machines is that they have no cutting force, so you can have like the floppiest, crappiest mechanical machine, and you will still it'll still print something.
Right. Versus just stopping, like hitting something and stopping.
Yeah, right.
And so then
I'm just going to stay here.
Because we're working on network control systems, we were also thinking about can you use one machine to control lots of different kinds of heads? So can you have a machine that's both a milling machine and a 3D printer and maybe some other things? And so Olan Moyer and I built a briefcase 3D printer, milling circuit board mill, vinyl cutter. Also has like a liquid handling head. I don't know if you've seen that, but it was we called it the pop-up fabrication device.
So I am on the MTM CBA MIT.edu, and this has all of the awesome. This is like so many great little machines on here. I love these things.
Yeah.
So that was the Pop Fab one.
Pop Fab, yeah.
Pop Fab. Yeah. Looks sweet.
So.
Oh yeah, this one.
So that one is all. That one is all water jet cut, and it has this cool timing belt stage design that Alon called the Core XY, which is it's pretty nice because it means that your motors are stationary, so you're not moving out around a whole lot of mass. So you can move it pretty fast, but it's because we made it pretty small, it still had enough stiffness to do circuit board melding. But that was a cool machine. So then we're like, oh, no, okay, we're changing out the heads. Where you have reconfigurable control. We're changing out the heads, and we have reconfigurable controls because for each head you need a few different kinds of circuit to if you switch between the spindle speed controller for the mill versus the extruder head for the 3D printer, it's slightly different. And so then we're like, oh, okay, so if we're doing reconfigurable software, reconfigurable electronics, maybe we should also do fully reconfigurable hardware. And so Alon, James Coleman, Matt Hirsch, Ben Peters, and I were all kind of like in this machine building. We all kind of like this machine building space, and we were not. None of us have like the same advisor, and we weren't even really in the same department. So we decided to like write a grant proposal to see if we could all just hang out together and work on machines for a while. So we did that.
Best idea ever.
Nice.
we go hang out in somebody else's workshop and work on things that we want to work on without the interference of our advisors? Yeah.
Was there a line item for like a beer fridge or anything like that, or?
It's really, really hard to get MIT to pay for alcohol.
Darn. Okay. Well, at least you got the stepper motors out of it, so that's good.
And so that's where we started prototyping the reconfigurable stages that you saw at Solid, because then we were starting to think, can we abstract machines also just to the degrees of freedom that you require in a machine. So James made all these super awesome concept drawings of how the machines might be configured, and so the workshop that we're in is run by this guy called Vladimir Kunetsov, and he has a super baller CNC mill with tool changer. So we milled.
Oh yeah.
we milled all of the original stage designs out of HDPE in like 20 minutes. It was crazy.
Yeah, those are awesome.
It was pretty fun.
Sweet.
The FlexiCam, the FlexiCam is a cool machine. Probably weighs only around 10 tons.
Yeah. Or they do like the cast iron like bases, so they're super rigid and super heavy, and they never will move.
Yeah, no, it's a nice machine. And so we realized that HDPE was kind of heavy if you wanted to stack 3 axes on top of each other. That was kind of untenable. And so then we started prototyping the stages out of sheet metal. So the ones that you saw at Solid are made out of bent sheet metal. And then they have kind of a standardized whole configuration for bolting to each other. So you can have like an XY stage or an XZ stage or an XYZ stage. So the thing that we had at SolidCon was a 4-axis hot wire cutter. So it was four stages bolted together into a configuration where we could control a wire with a spring that was cutting styrofoam. And so prototyping the electronics for that was just me connecting 4 nodes together instead of connecting 3 nodes together. And then the virtual machine, or writing the virtual machine for that, was also really trivial. I made two compound nodes, one XY, one UV, and then you can address them as a full XY UV move, or just an XY move, or just a UV move. And at first we were cutting airfoils with that because it's the kind of thing that you would cut with a 4-axis hot wire cutter. But we didn't think that we didn't really think the idea was coming across really well. So then we started cutting these super useful things that maybe you saw at Solid that say hell on one side,
like words,
and on the other. Right. Yeah.
Right.
Well, bugger all this mechanical stuff. When am I going to get a PCB printer that can actually give me a finished PCB and none of this milled rubbish and
I don't know, man.
None of this, printed carbon tracks? I want a real PCB. I want to push a button on a machine and out pops my PCB.
Well, Dave,
double-sided, plate through. I can even live without the silk screen, even the solder mask, maybe just a double-sided, plate it through hole, push a button, out it comes. Is anyone working on this? And if not, why not?
Well,
I want it. Damn it!
I think that is kind of exactly my point, where you want something and you're yelling at me, and I want you to want something and to just build it. And so I'm trying to make it easy for people like you to build your own machines, because there's nothing really that complicated about what you just described. But it's going to require.
Well,
you have to actually.
Well, there is.
No, not really. You're going to have.
Well, there's lots of manufacturing steps which go into your traditional PCB. That's what I'm saying.
Sure, but none of them are unsolved.
No, none of them are unsolvable.
Dave, she's so calling you out right now. It's awesome.
No, I just want some novel idea that somebody hasn't come up with. Yeah, every man and his dog's doing a PCB milling machine with a little bit, and you can mill off the excess copper on the board. Whoop-de-doo. But it's always a separate process where you plate the holes separately and you mill separately, or you etch separately, or you do. I want someone to come up with some clever manufacturing or materials process that gives me a finished fiberglass-like board with conductive traces that's as durable as a regular PCB.
Well, maybe
So I think
this is a good. No, this is a good
probably
question,
more
though.
more of a material science thing than just whacking some CNC motors on and coming up with some novel way to mill it. It's I think there's more to it than that.
Well, I guess my question would be maybe a better question than what Dave's asking or demanding.
Demanding, damn it.
What do you see? I mean, do you see this as so? Like you're talking about making things like easier to build these. Do you see this as being able to go into a production type environment ever?
The machine tools?
Yeah, like the.
Yeah.
So I mean, you're talking about like. Okay, go ahead.
Yeah, definitely. I guess my interest is in not necessarily mass manufacturing and economies of scale that work in that way, but more, small scale manufacturing to the level of personal fabrication. So like one of the use cases that I imagine when developing machine tools like this is not can I make something that already exists, PCB fab, that already exists in really quite a mature form, easy enough for Dave to buy and put in his house. Yeah, that's kind of that's not necessarily a super exciting problem, in my opinion.
Well, it's super exciting if it's a new materials process or something like that. That's what I'm getting at.
All right. Well, maybe we can argue about that in a second. And but for example, if you take like synthetic biology experiments right now, the things that people have to do, the things that you have like people sitting in labs doing right now by hand because automating it is too annoying.
Yeah.
So like
making it less annoying for them to automate it.
Right. Like so I'm a backcountry skier, and I have ski buddies, and and some of them are biologists, and sometimes, even though it snows, they won't want to go to the mountain because at 4:00 they have to like turn on a laser.
Right.
I'm talking about you, Drew. And so, yes, it would be really cool if you had a little box on your desk that would make 10-layer like blind via circuit boards for you in 5 minutes.
Yay. I don't care if it takes a day. I'm flexible.
And but I think that if in terms of possible new kinds of machines that you could build, one where you're incorporating thermal processes, motion processes, feedback from computer vision, like all of those systems, people aren't really doing that. I guess maybe George Church is doing that. That's why he has so many publications in science.
I don't know who that is. Sorry. Is that a biologist?
He's a I would say that he's like the biologist. I don't know if do you know the Wyss Institute at Harvard?
I've heard of that.
The professors there include Jennifer Lewis, who is working on new kinds of materials for doing things like 3D circuit design. So Dave might be excited about that. Mm-hmm. And also the robotic bee. I don't know if you saw that tiny robotic bee.
Yeah, I've seen that. Yeah, very cool.
So those are all from the Wyss Institute, and the Wyss Institute is directed by George Church.
Okay.
Who's also a professor at the Media Lab, which is tangentially related to the Center for Bits and Atoms, in that we're in the same building.
Yeah, got it. You're in the same cafeteria or something like that.
Well, we don't have a cafeteria.
Well, have you had lunch with George Church? Is that what I'm hearing though? Is that because that'd be pretty cool.
Yeah. Well, I guess this is kind of the cool thing about the Center for Bits and Atoms is that we have lunch with cool people all the time. So George Church, George Whitesides. If George Church is biology, I would say George Whitesides is chemistry. There's a lot of cool people called George, except for one. No, two. There's two specific.
Yeah, we're talking to you, George Foreman. We don't need your grill.
Yeah. It's poorly controlled anyway. Temperature curves.
Yeah, right?
Yeah, I know, it's awful.
So it sounds to me like you're trying to create a new toolbox for people. Is that an accurate statement?
Sure.
So what what are some of these wonky machines that so you mentioned that you've made some weird and wonderful little machines. What are some of the weird problems that you've solved or you've seen other people solve with these?
Well, so for example, Alon at some point wanted to make a loom, a CNC controlled loom, and he used electromagnets for controlling which things would pick and which things wouldn't. And so he decided to make those. So he needed to make a bunch of coils. And then he needed a bunch of custom coils. And where do you get custom coils? You could wind them by hand. Took a long time. Wasn't very precise.
You make a machine to wind the
exactly.
coils.
So he made a machine to wind the coils. And because we've been working on controlling machines easily and prototyping machines easily, I think he made the coil winding machine in like 2 hours, and it made perfect 50 ohm, or was it 8 ohm? I forget. Coils every time. Yeah,
that's intense.
And so then he used that to make the loom, and then the loom is like not a serious. It's a friendship bracelet loom. It's just like a silly project.
Yeah. I'm looking at it right now. 24-bit friendship loom.
Exactly.
Yeah.
And so lowering the barrier of entry for automation so that you have access to more precision enables you to build things that you otherwise wouldn't. And I think that part is really exciting.
Got it.
Yeah, Neil's book kind of talks about that too, because of like when they pushed the Fab Labs over to like
I
West
totally
Africa or something
haven't
like that.
read Neil's book. Okay.
Oh, I won't tell him. That's fine. But I'm telling you right now. But it's basically that. Like when you open up access, like all of these different applications pop out that most people wouldn't think about.
Yep.
Actually, that's probably a really good example of this, where like there's stuff around a low-income village that might need a tool, but they can't actually even get to the point where they're making the tool. So you should read his book. He's a smart guy. So telling.
I talk to him every day. Don't worry.
I know. Well, that's fine too, I guess. I guess you probably get some of that then. Yeah, this is a cool looking thing though. Like, and it's just like a wood cut little magnet machine.
Yep.
I guess, huh?
Yep.
Huh.
And it has a browser interface. So like your question about like, is it Python or is it Erlang or whatever, like people are relatively proficient at using browsers.
So you just click and point and it goes, that kind of thing. Yeah.
Yep.
My 3-year-old can use a browser.
Yeah, amazing.
That is interesting too. So like, so what would it take for one of us to get started here then? So design files for the axes are on GitHub or anything like that, or is this stuff published? Or
yeah, if you click on like the reconfigurable stage tab in the MTM site, you can see where like the cut files are linked just right from that page, and and then the code run the interface, or the code that runs on the nodes, and then the code for the interface is also linked in GitHub, and the bill of materials and the schematics and stuff are also all there. I don't know if you see them.
So what about did you design the circuit boards as well? I mean, like,
yeah.
Are they just drivers on board, or are they micros as well? What are those?
Yeah, so that's it's an Arduino compatible board, so you can program it through the Arduino bootloader too, and then you can also program them in the network. And then it has the one that runs those reconfigurable stages has a stepper motor driver on it, an Allegro stepper motor driver. It has a really cute key sync on it. I don't know if you see that. And so
I do like Allegro parts, except when you're trying to buy them, they can be a little bit nasty to buy sometimes.
Yeah,
they're hard to find in the marketplace.
Yeah. I'm trying to keep it relatively portable. So if you wanted to use a different stepper motor driver, you could, like the Vladimir and Dimitri and some of the people that were working on during the cool workshop where we started all of this, they prefer TI. I don't know, like everybody has their own preferences, and so the motor driver component is separate from the communications component, and so switching them out is theoretically trivial.
It's just you're just sending pulses usually, right? Isn't it just like you send pulse trains and then it's just amplifying the pulse trains? Is that usually what it is?
But you would have to change the firmware for the microcontroller, and maybe that you like that or maybe you don't like that.
Oh. Yeah. I mean, I guess if you're switching parts on a board, you're probably pretty prepared to switch out your firmware, or you should be at least, right?
Right. Yeah.
So where does the virtual machine live then? Does it live on, I'm guessing it's a 328 Atmel 328 on there?
No, the virtual machine lives in your computer.
Okay.
And
so that's just because it's running Python. The Python is
yeah. So your virtual machine could be implemented in Python. So let's say it is. So you have a machine that has different parts that you can call functions on, and that so like that, say it's a class, say that class that you're calling functions on subsets of, that is what I'm calling the virtual machine. So it could be any other language too, if that's what you prefer, but it has a persistent connection to the networked nodes.
And when you say networked, you just mean, I'm looking at the pixture now, and it says just daisy chain, just to, if they're just getting like unique addresses basically, and driver 1 is, you just say you are X, your x-axis, number 2 is y-axis.
So when you plug them in, if you don't have a virtual machine configuration file loaded already, they'll flash and they'll say, they have that little button on them, so all the nodes will flash, and it'll say, okay, please identify the X node. You press the button on the X node, please identify the Y node, please identify the U node, please identify the V node, and then that will get saved into a machine configuration file. So next time you plug in the same machine, it'll know what it is.
Oh, that's fancy. So how far do you want this to go? I mean, like, so there's lots of good pictures that people can, we don't need to describe them on here, and they can go click through to them, but where do you want this to go? I mean, like, what do you, do you want to see this supplant a Haas? I mean, or do you not care where it goes, or what's the plan?
I mean, I don't necessarily think that I don't necessarily want to supplant Haas, but I do want people to have access to small scale automation that currently don't feel like they have access to it. I feel like the lack of access to precision fabrication and automation for researchers like me is, in a way, like being stuck in the Stone Age fabrication-wise. It's like controlling what your output can be, and I think that really needs to change if we want to be making different kinds of technology.
What are the main items which we need to, or the main materials or things that you need to process? Have you got a list of like, we need to process, we need like ABS plastic. We need to do, we need to cut styrofoam. We need to cut metal. We need to cut all these things precisely. Have you got a list of materials?
For manufacturing?
A dream list of materials? Yeah, for manufacturing all the stuff you want to manufacture.
I'm not necessarily just thinking about manufacturing. I think that just automation in general is something I'm interested in. And so, like if you look at Amazon bought Kiva Systems, right? So there's like a robot that moves around things in a warehouse, and that's now owned by Amazon, and Amazon is going to start being the only, or not the only, but the most efficient warehouse moving company. Therefore, the people that are going to sell you most of the stuff, and that results in centralized control, and I'm sort of opposed to that. And so,
okay.
And so, how do you make it easy for someone to say, oh, like the only thing that Kiva Systems robot really does is like move in a grid tile, move around in a grid and bring different things to different people. So how do you make it easy for people who are interested in doing the software of warehouse automation and the robotics of something? How do you make it easy for people to continue developing those things? Because what I see right now is that there's this sort of techno elite that is able to make stuff, and it's controlled by a certain kind of person.
And evil patents and things like that.
Yeah.
And
patents are evil.
Well, I don't know if patents are evil or not. I think patents are an incumbent. I think patents are an incumbent system that you can't just say it's good or bad. It's something that you have to deal with.
Yeah.
Yes. And the way that certain companies deal with patents, I do think is bad. Like if you look at 3D printing right now,
Oh,
I don't know if you guys are familiar with Form Labs, the 3D printing company.
Yes.
So Form Labs came out of the Center for Bits and Atoms, or at least Max Slabowski.
Yes, they did.
He was from the Center for Bits and Atoms, and they're being sued, or they're constantly being sued by 3D Systems, who is one of the two big players in the 3D printing market, and that's just a scenario in which patents are obstructing innovation. And 3D System chooses to use them in that way. Maybe because they don't have any good engineers of their own.
Oh, shots fired.
No, I'm sure 3D Systems has plenty of competent people because they acquire competent people all the time.
That's right, they do. There's only two printing companies left. It's them and Stratasys. That's it. They're huge.
Yeah, exactly.
I mean, once Objet got bought, it's just like, okay, well, now we're down to two.
Well, there's EOS.
Oh, yeah, that's true, yeah.
But anyway,
scale-wise, they're not as big, right? I mean, they're...
I guess my point is that for Form Labs to be able to participate in that space, they have suffered so much. And they really are building a product that I think is pretty cool.
Yeah.
I thought they settled that, though. I thought
they settled the first one. There's a second.
Oh, okay. There was another one after that. Right.
I really don't think they're going to let up on it. I don't know. Did you guys see that? Did you guys see that documentary, Print the Legend, about 3D printing? It's like
no.
So it has like three main actors in it: Max from Form Labs, Bree from MakerBot, and then Avi Reichenthal from 3D Systems. And Bree. People have opinions about him. I've met him. He seems like a nice guy, and I understand that going from an open source machine to a closed source machine alienates your audience, and kind of maybe he's a little bit of a tragedy. But I think that in the movie, Brie Pettis really gets vilified for wanting to be like a Steve Jobs-esque asshole, control, evil empire, whatever. And maybe some of that criticism is fair, but at the same time, like MakerBot was a small startup working in the 3D printer space and had to contend with big players, including 3D Systems and Stratasys, and they don't receive hardly any criticism for their behavior in the marketplace in the movie. But otherwise, it's an amusing movie. You can see.
Oh, I'm going to have to watch this.
Yeah.
Because, granted, Breen didn't necessarily have a choice because back in the early days of it, a lot of people bought in to MakerBot, so he only had a certain amount of say in what went on. They took, venture capital funding and things like that. And once you do that, you don't make the decisions anymore.
Right.
So you just have to either choose to completely leave and quit or go along with the ride.
Right. Yeah.
And that's what he did. And now he's, worth hundreds of millions of dollars because he decided to go along for the ride. And, well, I don't blame him for that. So, it's a tricky thing. It's a tricky thing. When you do these startups, you give away your choice, really, to drive the direction. So
maybe.
Unfortunately,
Alon left the PhD program to do a startup, and maybe it's just because it's in the early days of their startup, but they're making like a CNC hand tool. So it's like you do gross positioning by hand, and it does small positioning.
Wait, they're not the router, are they?
Yeah,
is that them?
Yeah, that's them.
Oh my God,
Tech,
that thing is. Oh, that was so. Oh, jeez. I think I talked about it on the show a couple.
Nerdgasm.
This one was so great though. So it's a computer vision. They have the stickers that go on the wood.
Yep.
And then it's basically like a handheld router.
Imagine you needed a non-repeating pattern to be printed on masking tape. How would you do that?
Does it have to be different tape to roll to roll?
Well, the pattern has to be non-repeating for all of the tape that you put down on the material that you're cutting. And so if you get tape manufactured, you can print a repeating pattern on tape, but non-repeating patterns are not something that is available for you to buy. So what do you do?
Oh, I have no idea.
You build a machine. So one of the things that they did was build the super cool router that you saw. But another thing that you haven't seen is that Alon also prototyped a tape printing machine to print non-repeating patterns on tape. And he's able to do that
story.
because we build machines.
That's right. You should lead with that. You should definitely lead with that. That is really cool. So, wow. So wait, so they're gonna just end up manufacturing their own tape then too? I mean, like that's
Yep.
Or
I think so. Yep.
Huh.
Or maybe they'll manufacture. Maybe that's going to be like the actual thing where the investors say, we don't care about this router anymore. You guys just have to become a tape printing company. But I don't know. So far, it seems like their investors are like relatively cool. And I guess now,
there's no such thing as a cool investor. There's not. They might be relatively cool at first.
Does that mean that they have a load tape button on their machine too, like the one that you were talking about?
No, because
that actually would make sense.
Because you put the tape on by hand.
Right, but you need to like load it when it's like looking at the tape.
Once you put the tape on. I don't think that there's a button that says load tape, but I'll suggest that. I bet Alon would think it's hilarious.
There you go. Yeah, that's good. So what's it called again? So because I mentioned it, but that thing is going to do so well. Like it is the coolest machine.
Tactia. Well, actually, they haven't actually named the router tool itself yet, but the company they call it Tactia, Taktia.
Okay, TAK. Yeah.
I think they're going to kickstart that at some point.
No.
Yeah.
I'm shocked.
So I had a question about that too. Do you feel the urge ever? Are you like, you know what? I mean, like, so like Alon did this, right? He left the program and he's just kind of like going off and making this thing. Do you ever look at one of the machines you make and you kind of like scratch your head and you're like, this is the one. This could be it. Do you ever feel that urge or no?
No. It's really fun.
All right.
It's really fun to make more machines, and I don't know. So there's lots of people at MIT that kickstart things. And even small kickstarters do you guys know Public Lab that make open source science and instrumentation tools? And so
I don't know my name. Maybe their tool. What do they make? Like
$10 spectroscopy tools.
Oh.
And so,
nice.
They did the kite mapping of the Gulf oil spill. And so they sell kite mapping kits on Kickstarter. Anyway, so I watched some of my students at some point did a Tesla coil for Valentine's Day Kickstarter. I don't know. I've watched.
I saw that one. Yeah.
I've watched a lot of people fulfill Kickstarter campaigns, and it just doesn't look like that much fun.
You don't like doing T-shirts and stickers as well? Dave's done one. He can tell you all about the. Dave, are you done yet? Are you done fulfilling yet?
Yes.
Yeah, finally. Yeah, it took him about 6 months. Yeah.
I guess there's certain things that I do think are really exciting. Like, have you seen the open source hardware laptop?
Oh yeah, Bunny. Yeah.
Yes. Yeah, Bunny. Yeah.
So that's
very cool.
That's cool. Like, and I think one of the things that's super cool about the Novino laptop is it's not just a laptop. Like, as a laptop, it's not even as a laptop for most people. It's really not that useful.
Right.
Or
as a platform, right?
But as a platform, it's cool. But I think the thing that I think is most cool about it is that I think in a way it's a kind of investigative journalism to figure out, can you manufacture things at a affordable, if not cheap, price point using industrial manufacturing processes. So not like the Tesla coil where you make everything yourself and then ship it and then hope everyone is satisfied, but can you design a board, keep everything open the way that you want it, use crowdfunding to go into production and make something that any investor would say, this is not a business model, you can't do this. And like Bunny and Zob's, you know, Bunny's is an electronics guy and Zob's is a software guy. And like neither of them are manufacturing guys, right? So are we getting?
I'd say Bunny writes about manufacturing all the time.
Well, he learned. Yeah.
Anyway, sorry. Sorry, I shouldn't cut you off.
I guess manufacturing hardware, but not manufacturing mechanical things. And granted,
Right.
like a laptop is not a very complicated mechanical thing, but it's still, I mean, they're CNC milling aluminum. They're going to injection mold ABS.
Well, to do a modern laptop's very like a modern
Yeah.
Mac or something.
It's fiddly bits.
Laptop is it's all about manufacturing. It's all physical mechanical engineering.
Right. And all of that,
anyone can lay out the board and do the PCB side of things.
Anyone. Bunny, you're so trivial.
Well, no, but
Dave says that 'cause he's the
electronics designer, right? Who can lay out boards.
Anybody who's worked at Altium as a
design that
PCB
thing.
designer could definitely lay out a circuit board like it's no problem.
A motherboard,
yeah, exactly.
It's not a problem.
Yeah, DDR3, no big deal. Right?
And
yeah, no, it's not.
all right. Well, I think they have some more boards that they're working on. If you want to, if you want to lend a hand, it's an open source project.
Yay! I got plenty of time to do that.
No, but I think that the cool thing about it is that this is kind of a new point where you can specify something that you need without being an expert and still get it manufactured and have it be something that is useful at the level of not being a toy or like a kind of a gimmick, but it's like a real tool.
That's true. That's an interesting look at it because, I mean, some of the Kickstarter campaigns are pretty in depth, but usually they have some clout behind them. Whereas it's not just a couple individuals that are doing it. So.
Well, they're like hardware. I hate this term, but they're hardware accelerators. The first time I met someone who said that they worked at a hardware accelerator, I was like, oh. No, someone is like, I run an accelerator. And I said, linear? And then they were like, you are retarded. Who are you? What are you doing at this point? And so anyway, hardware accelerators, some of them, there's like one in Boston called Bolt, and they kind of partnered with Dragon Innovation, I think they're called, and
that's right. Yep, that's Scott. Yep.
And they do all.
They've been on the show. Mm-hmm. Everyone's been on the show.
See, it's a small world, and they do. And I guess Dragon Innovation are the people that have the expertise of how to manufacture things in China. So they did the fulfillment for iRobot, and then as I guess maybe the cohort or the person that's doing the product, you don't necessarily learn that much about how to get things manufactured in China because they already have that expertise. However, what if you want to build something that they don't care about? How do you have access to?
Well, you probably wouldn't go to their program in the first place.
Yeah. First of all.
Could you give me $30,000 for 6% of my company you don't care about at all?
Yeah. Have you noticed that their accelerator is called Bolt and yet their logo is a nut?
I did not notice that. That's a good catch.
So,
you should bring that up with them.
I've mentioned it. I think that mostly. I think I'm kind of annoying.
It's funny.
I know she comes again. She's going to mention it.
Who is that crazy person?
So you're saying that the idea is like that you think it'd be interesting to move outside of a system where you need infrastructure to build a lot of something. That's what you're saying. Is that kind of the point behind this?
Well, I guess it comes back to this notion that I think autonomous infrastructure would be a good thing in case you want to manufacture something that isn't necessarily something that's supported by the status quo of infrastructure.
Okay. And I mean, and I guess you could argue as well. I mean, so a lot of these things they push their way into the mainstream as well, right? You say, okay, well, why would you need a router with a stepper motor on it in the first place? But then when you go and try and sell it to furniture makers, they're like, hell yeah, right? The Tactia thing that Alon's working on, right? That, I guess it makes its way into the mainstream as well. Eventually, someone's going to be like, yeah, we'll make it into a real thing.
Yeah.
Or a mass-produced thing.
Yeah.
Well, that's pretty crazy.
I don't know, is it? I think this is all just kind of like steps in the obvious directions.
I guess so, but if I look at what you're doing, I never would have been like, yeah, I would go make tools that make tools. Like that's not a. I mean, it seems like you got there over time as well, but it's not like a natural progression to go backwards. Like not backwards, but like to go back to the primitive levels where you're like, oh, we need to break this down to modular machines. So I guess that's what makes it interesting. is that you have to kind of break it down to build it back up, right? You're not saying that I'm going to start with a CNC machine. You're saying I'm going to break it down to a single axis, abstract that, and then build it back up to something that looks like a CNC machine.
Yeah. I don't know if you're familiar with other research from the Center for Bits and Atoms, but generally everything that we do is like small things that connect together, that have local behavior, that have some kind of emergent global behavior.
I did see I saw a presentation from a couple years ago. I think it was a similar like kind of networked small thing machines. It might have been Neil that was presenting or something like that. It was like in a boardroom.
Well, so
it was the same kind of thing.
It's also like, for example, Kenny Chung, who used to be a PhD student at the Center for Bits and Atoms, now he works at NASA, and he does small. He does these like small shapes made out of carbon fiber that you can snap together to make aggregate carbon fiber structures. So you can have space filling carbon fiber stuff, and like the final material that you're engineering there doesn't necessarily have the same material properties as bulk carbon fiber, but you can approximate a stiff, light material.
Right.
But make it much lighter because you're using this engineered material.
Yeah.
So that's an example of like snap together something. So he's not snapping together electronics; he's snapping together materials. Or there's another student who at some point worked on snapping together small propellers so that you could make, instead of a single flying object, you have something that's more like a flying carpet. Also the processor design that was kind of before my time at CBA. It was the same thing where you need more computation, you add more processor nodes instead of.
Sweet.
So does a lot of this stuff come from like computing surplus, like the fact that micros are so cheap and everything's so cheap? That's the idea, to kind of distribute the processing idea.
For the processor, so that was called.
Oh. I just meant in general, like even I guess not carbon fiber stuff, but like your stuff, right? I mean, you're pushing control down locally to the nodes, right?
Yeah.
I mean, the node design is the idea of everything does its own processing, and then you just give it these abstracted
packets.
commands.
Yep.
Yeah. There you go. Yeah.
Sure. Yeah. I have never really thought of the possibility of microcontrollers being expensive.
Well, go back 20, 30 years when I mean, like when like the Haas machines we see today, like the big ones, right? Those were all based on mainframe, or like old stuff is all mainframe centralized servers, right?
Yeah. I guess you're right. Sure. Cost is not something that factors very heavily into academic research.
I never would have guessed
that. We're stunned.
No, but it's definitely something that we thought about. The microcontrollers that we use, I think we always try to use ones that in quantities of 100 or less than $4.
Yeah.
So yes, I'm going to go with the answer is yes.
Okay.
Well, you don't have to. It always comes down to the best tool for the job. You know, if your micro costs $100 and it's the best tool for the job, well, use it.
Right, but you're not going to see that pushed out in the world in a practical implementation unless it is.
Well, it depends on what sort of market you're in.
As well. Yeah.
No, exactly.
If you're using a $100 ADC to replace a $3,000 oscilloscope, then it's pretty cool, no?
Exactly.
Yeah, but I mean, so here's my thing, right? So people you work on you like modularity and stuff like that, right? Mm-hmm. And oftentimes when I've looked at modularity stuff in the past, people are like, well, you just put FPGAs on everything, and you have these standardized interfaces that are 100 pins wide, and they use these fancy Samtec connectors, and everything works great. And then then you look at the BOM, it's like $1,000 per node,
right?
And it's less good.
Well, I mean, I think that if you have did you guys see Project Ara, the phone that Google announced?
Yeah.
So Ara used to be a CBA student too. Oh, it's named after this guy Ara, who used to be a CBA student. I
did not know that.
And he's making and he's designing like the modules that are going to make up Project Ara, the phone. And so they're using like a high-speed interconnect where they have to design things communicating very quickly in a way that not kind of
SerDes, something like that. Yeah,
they're going to have fancy ass connectors. And I think that they're not necessarily thinking about the possibility that each of the individual nodes that they're developing right now is very expensive, because they have the expectation that they're going to be manufacturing that at scale. And so then the cost that the prototype costs right now for them is irrelevant.
But I mean, I guess there's that assumption. But then, I guess the only thing that thinking really helps is like that, like you mentioned at the beginning of the show that sometimes you have to push the limit. Oh, it was the Gary building thing you said. Sometimes you have to push the limits in order to, force them to change manufacturing processes to make things cheaper. Yep. I could see that making sense.
Yeah. So I think that's what they're hoping is going to happen with the Project Ara thing. I mean, they're doing a lot of things with the Project Ara thing that, I'm going to see it and then I'm going to believe it. Like they want to do a machine that prints the entire phone. So it prints the circuit board and the enclosure and the display and everything in one machine. Good luck with that one.
Yes.
No, but I mean, I think it's one of those things that is theoretically possible that it's going to require a metric shipment of engineering.
Yeah, right, and that could be a good thing, right? Yeah.
And so I guess it depends, like who is angling effort in what direction.
Right.
My thing is always with those, like the R is a good example too. It's like it always becomes the problem with modular systems as well is like it always becomes a lowest common denominator problem. Like if you have a module that you want to plug in that's an LED, you want to light something up, but the connectors and everything else on the, basically you're flipping a bit, but you need to have all the other infrastructure there in order to flip that bit and to push it down through. That's always the problem with modular systems as well, is the overhead on a node cost basis. Mm-hmm, mm-hmm. I'm such a downer, aren't I? I mean,
no, but that's been around. That argument's been around forever.
We were talking about before the show about
modular hardware,
a modular system that someone in this call had designed. That was a little pricey.
yeah, a little pricey. Altium. Yeah. And yeah, it's always the same when you try and do things modular like that. There's a very niche window where it's viable. It's always going to be the case. Always.
Yeah. Well, and I think it's one of those things where you can always say it's a bad idea, and you can always try it anyway. And probably if you work hard enough at it, you'll figure out some way to make it work. But you have to.
It's never a bad idea. It's just niche.
Yeah. You don't want to be the person who's like, "Oh man, that was a terrible idea," and then like they go off and do it.
Right.
Yeah.
You never need more than 5 computers in the world,
right? Computers in the home. What nonsense.
Yeah, seriously. So you've been traveling a lot for conferences. Are people going to be able to hear you speaking at any future conferences?
I'm going to be at the Open Source Hardware Summit. I'm going to be talking about sourcing and open source hardware.
Oh, cool. That's a good topic.
Awesome.
So that'll be in Rome. Right?
Sometimes I think one of my core competencies.
Oh, yeah, that's in Rome. That's right. Yeah. It's moving, isn't it?
Yeah, it's going to be in Rome.
Jeez, that's rough. Gosh darn it, you have to go to Rome.
I've never been to Rome.
It's pretty awesome.
Yeah? All right, good.
Yeah. You'll love it.
So what is you said that's one of your core competencies is sourcing parts and stuff?
Oh, I was going to say that was one of my core competencies is knowing how to buy shit. Sometimes people just don't know what the thing is called that they need.
Oh, yeah.
Oh, yeah, totally.
Those are obviously people that don't spend lots of time reading part catalogs.
Yeah.
Well, no, that even happens to me. I've been in the industry forever, right? And I know a connector, but I won't know the name for it.
Right.
And I go, oh, look, I know that bloody connector. That's the one I want. But I can visualize it. I can picture it. I'd pick it out in a catalog, in a visual catalog. But you think I can get the name of it? No.
Well, that's a kind of a thing that's been I don't know about a problem, but at least a challenge for the Fab Lab network, where we don't only, for Fab Lab, specify kind of a shared set of tools that people should have access to, but also a base set of materials and parts that they can prototype with.
Right.
And so,
yep.
Maintaining that base set of parts. So I was talking about it with Bunny at some point, not so long ago, about could you specify a base set of machine parts that people could buy and build machines from, and that's kind of hard because machines that you want to be that should be custom designed should also have parts that are specified for the application at hand. But if you go down that road too far and you do everything custom, then if it's an open source project, how is anyone supposed to replicate what you did?
Right.
And I guess there's different levels of open sourceness. Maybe you just have it open source so that people know what it is, how it's running code, and what that code is. Mm-hmm. But I, part of being of the school of modularity is also like wanting users to extend things, and if you can't buy things that you're able to incorporate into your projects, then you also can't really extend them. And I think that's a big difference between open source hardware and open source software, or should we call it free hardware?
Uh-oh. You gonna go all Stallman on us?
Yeah, it's not going there.
Let's defer. Let's defer that discussion.
Next time. You can see Nadia speaking on the free hardware ad.
I don't necessarily want to. I don't know if like open source hardware is a. I don't know if open source hardware is a fair description, because it seems to imply that with just the design files, you're enabling people to interface with the hardware. I think that's kind of a misnomer. So maybe free hardware is a better. Yeah. But free hardware also just sounds like you can get free hardware.
Right.
Sounds like free. Give it to me for free. Damn it. I'm not buying that crap.
Hey, what you calling crap?
Yeah. No, that's the talk I gave at SolidCon. Was about open source hardware, but like if the I don't know if it's that talk, but it was basically about if you aren't using open design file formats, how deep does it go, right? It's like the inception.
Well, it goes right down to the silicon level. The AVR processor in the Arduino is not open.
Right, exactly.
Right? So, yeah.
Right, and you couldn't replicate the 328 on your chip printer.
No, exactly.
Right.
Yeah, you're tied in.
Yeah.
Nadia, can you make me a chip printer?
A what printer?
A chip printer? Could you make that for me?
Dude.
How much do you want to pay me?
That's a long-standing.
It's not a matter of paying. It's just not possible. It's a trick question.
It's a long-standing point of
argument/joke here on the
more of a joke these days.
It is a joke because it's not manufacturable.
But basically, Dave and I had a bet a while back about will a chip printer ever be possible on the desktop in people's homes?
Well.
The answer is no. Once again, it's a trick question.
No, I'm just saying if she would make it, that would be a lot easier for me.
I think that like there's like technical impossibility, and then there's complexity impossibility, or I don't know, what should we call it? Like there's things that like this is not a thing where you're like, okay, if we worked, it's not in some limit where you can say this is physically an impossibility, right? Like but it's kind of practically an impossibility because
it's just dumb.
Bingo.
Nobody's going to work on it, right? There's not enough people like Chris who want this, and I like it.
You're saying I have to make it because I want it, mostly just to prove Dave wrong.
Yeah, sure. Or like if you were Richard Branson and felt like spending $1 billion on it, I bet you would get it.
You can't even build a traditional fab for $1 billion. Give up, Chris.
I'm not going to give up, Dave, but I will accept that Nadia will not build it for me. That's fine. She doesn't. It's not her job. That's fine.
Oh goodness.
I can make a potato chip machine for you.
Well, that's a good start, actually. Yeah. Chip printer. Oh my God, we found a loophole. Chip printer on the desktop. It's a potato chip printer.
There's a semiconductor company called Potato Semiconductor.
Really? What do they make?
Yeah. They make TTL, like really fast TTL chips. But it's like almost one guy in a garage. I'm not kidding. It's like, But you can buy one. You can buy them on eBay. You can go to eBay and buy potato semiconductor chips. I kid you not. That's their name. Potato semiconductor.
No, I see it. Their
Anyway.
USA office is in San Jose. Why
Yeah.
called Potato Semi as brand? This is even better than Altium's website. We are the IC design house making chips. Potato chips are the most popular chips in the world. They are high volume, low price, and taste good. All of the people like to eat them. All of
can't
the
tell if
people
she's-
are happy with them. This is exactly our goals. I'm just reading from PotatoSemi.com's About Us page.
Oh my god.
Yeah, it's great. Oh, I love it.
All
And if you hit their online store, it takes you to eBay. It's great.
There's a sourcing problem for you.
all the computers and electronics devices like our chips taste.
Oh, God, don't get me started.
Nadia, we should probably wrap it up before we get into other ludicrousness here. Where can people find your work online to go check out more of your stuff?
You can see all the machines and their source files, their free files, whatever you want to call it, at mtm.cba.mit.edu. And you can read I call it my invariably irrelevant weblog at infosyncratic.nl.
Why.nl?
I'm Dutch.
There you go.
Simple answer, huh?
Makes sense. Sorry. Duh. Of course.
That's one of those nice things about you're like, we might live in a cosmopolitan, globalized society where everything is on the internet, but the internet is still geolocated.
That's right.
Yes.
Yeah, they don't let you get Estonian .ee TLDs. I looked into that at one point.
Oh, really?
I really wanted a .ee TLD.
Even if you know someone in Estonia?
Well, yeah, maybe you could do that, but I thought that'd be fun.
Yeah, that would be funny. .ee. Yeah, .it is popular.
Oh yeah, Italy. Yeah. All right, cool. Well, I look forward to seeing more of these machines and hopefully building with some of them at some point too.
Yeah. Oh yeah, I forgot to tell you about the rotary ones, but whatever. You'll see it online someday.
On the webs.
Like next week.
Yeah. Cool. Well, thanks again. Thanks for being on the show. We appreciate it.
Yep.
Yeah.
Thank you very much, Nadia.
Nice talking to you guys. I'm gonna go boot back into Linux now.
Okay. We're sorry about Windows.
Okay. Okay, bye everyone. Bye.
See ya.
All right, I gotta go work on my potato chips.